Good morning again. You're welcome. In order to be on time, like yesterday, we finished yesterday with half an hour late, but I think it was very interesting, all the presentations. And now I'm going to introduce Susana Bulnes. She's a researcher of our Department of Neuroscience in the Basque Country University. Thank you, Susana.
Good morning, everyone. I want to thank for inviting me to this meeting, to the network in Bilbao. It's my home, as you know. And of course, I thank Dr. Pomposo and Dr. Hill for giving me the opportunity to talk about my glioma model and my research with stem cells. I will start. As you know, glioblastoma is the most malignant tumor of the brain because it has a high mortality, and usually after the treatment with radio or chemotherapy or after the tumor resection, there is a recurrence of this tumor. And I wonder why does it happen? Recently, there are a lot of theories about the specific cells within these tumors which have the capacity of the tumor recurrence. These tumors have the chemo and radio resistance and the capacity of the self-renew. These tumors are called glioma stem-like cells. Then, after tumor resection, these tumors lead the tumorigenesis and the tumor progression process. A lot of papers report that these glial stem-like cells come from neoplastic cells which have acquired the stemness phenotype, and the hypoxia has a pivotal role in this adaptation. Moreover, in the tumor progression, they use the microvascular network to infiltrate the brain tissue. And, of course, it is believed that they play a pivotal role in the angiogenesis process because they induce the synthesis of angiogenesis factors such as VEGF, the vascular endothelial growth factor. Then, all of these things taken into account, we started to study the relationship between these glioma stem-like cells and the angiogenesis process, and moreover, we wanted to know when they appear during the tumor progression. To do this, we use a model, experimental model, glioma model, concretely, and we induce the gliomas by transplacentary administration of a carcinogen called INU, N-ethyl N-nitrosurea, and after this, we diagnosed the tumors using MRI, necropsy assay, and histopathology study. Then we follow it the microvascular network by Lea histochemistry, vascular permeability, by immunohistochemistry for enos and blood barrier, by the EVA, GLUT1, and a disection protein, occludin. Then, stem cells were marked using two antibodies called CD133 and nestin, and the angiogenesis process was followed by the VEGF 165 isomer. After this, finally, we made a relationship between the angiogenesis process and the stem cells using two molecules such as NOTS1 and osteopontin. These molecules are related with the angiogenesis process, as well as the maintenance of the stem cells. Our results reveal that our glioma model starts as a proliferation cell mass. No, sorry, Jesus. As you can see in the first picture, in MRI image, this proliferation cell mass become a low-grade glioma, more or less at 5 months of rat age. After this, this mass become anaplastic glioma at 8 months of age. And finally, we found the most malignant stage of this NU glioma model, corresponding with the glioblastoma at 10 months of rat age. Following the microvascular network, we found that there was an aberrance tendency from tumor vessels similar to the normal ones in the first picture, in the low-grade gliomas, to an aberrance huge dilated hypertrophic vessels within the glioblastoma and glomeruloid vessels typical of the border of the glioblastoma. VEGF as well as INOS, immunosuppression, increase in order to the glioma progression, as you can see here. Sorry. Increase in red, you can see in red, increase in order to the glioma progression, and we found that their overexpression was found in the intermediate stage corresponding with the anaplastic glioma. This expression for the VEGF, of course, was found on the border of the tumor. This border is the neangiogenic border. And in this stage, the anaplastic glioma is when hypoxia phenomenon happens, as well as angiogenesis starts. Right, investigating the stem cells using the two markers, nestin and CD133, we found that there was an increase of both of them in order to the glioma progression. Nestin was shown in the stage 1 in low-grade gliomas, whereas CD133 only was found since intermediate stage corresponding with the anaplastic gliomas. Stem-like cells were found within the tumor as isolated cells, as you can see with as you can see in the B picture. Isolated cells within the tumor are these nestin-positive cells were found also grouped around the aberrant vessels and around aberrant vessels like this, huge dilated vessels, and forming the necrotic palisade in hypoxia areas. And here you can see these cells associated with the glomeruloid vessels of the border of the glioblastoma. I want to remark one specific structure that you can see here, this one and this one. This structure corresponds with the nestin-positive aggregates, cells aggregates, and these structures caught our attention, and we call as spheroid-like aggregates. You can see here, this is one of these, and these spheroid-like aggregates increase in size and in density in order to the glioma progression. They were found in low-grade gliomas too. And they were composed by different population of neoplastic cells with a specific role. Here you can see this is the spherule-like aggregates, like this, and we can see the nesting CD133 positive cells in this, within this structure, and the VEGF positive cells surrounding this one. The NOTS1 was our study, and we found that the NOTS1 positive cells process of cells were positive for the NOTS1 and were located surrounding this structure. Finally, we studied the osteopontin, and osteopontin also, the immune expression of the osteopontin also increased in order to the glioma progression. This molecule is a prognostic of glioma, and we found that in advanced stages, the cells were located on the border of the tumor, as you can see here, on the border of the tumor, and these cells have the astrocyte shape and show overexpression and co-expression of VEGF, CD133, and nestin. Finally, a quantitative study showed us that there was an osteopontin and CD133 immunosuppression, similar immunosuppression. And after this, we can conclude that different populations of glioma stem-like cells are distributed in spherule-like aggregates and in the neoangiogenic border. NOTS1 is related to the spherule-like aggregates and could mediate their proliferation. Osteopontin and VEGF are pro-angiogenic factors synthesized by stem-like cells in the glioma periphery and could play an important role in the invasive process. And finally, the best, treatment with anti-NOTS1 and anti-osteopontin in the low-grade gliomas could mitigate their proliferation. And here is, I show you my team research, Laboratory of Clinical and Experimental Neuroscience in the Neuroscience Department of the University of the Basque Country. Thank you for your attention.